Hey everyone, and welcome back. If you have ever wanted to break free from the confines of the 2D viewport and attach your UI directly to your 3D world, today's video is for you. We are super excited to announce a massive update to the SimpleMeshWidget plugin. We have supercharged it. Now, your SimpleMeshWidget isn't just for displaying a mesh, it's a full-fledged panel widget that can parent other widgets and attach them directly to the bones of a skeletal mesh. Alright, let's get started. First, we are going to create a simple mesh widget that plays a skeletal animation. At this point, we have our mesh displaying just like before. But now, the simple mesh widget can now act as a container, just like a canvas panel. Now, let's drag an image widget as a child of the simple mesh widget. As you can see, the image widget is currently displayed at the origin of the 3D model. This is because we have not specified a target bone yet. By default, the child widget is attached to the skeletal mesh component's location. Next, let's go to the Simple Mesh Attached Panel slot category in the Details panel and modify the attach parameters. Let's use the Attach Bone drop-down to select our target. I'll quickly cycle through a few different bones to show you how the widget instantly updates its position. Now, let's talk about controlling the size of our child widgets. By default, just like in a canvas panel, the child size is calculated in its own local space. This means if I change the overall size of the main mesh widget, child image widget keeps its original size. It doesn't scale with the mesh. Now, let's switch the size space parameter. I'll change it from slot local space to mesh world space. In this mode, the image widget's size in the UI layout is now calculated based on the 3D world space of the mesh. Now when I change the main mesh widget's size here in the UI designer, the child image widget automatically scales to match. Next, let's explore how to control the orientation of our child widgets. By default, like any standard widget, it's locked to the screen's horizontal and vertical axes. We can break this constraint using the axis space parameters to map the widget's up and right axes to any 3D direction. First, I'll change the up axis space from UI space to mesh world space. This allows us to define the up direction in the mesh's world. Let me set the up axis to 0, 1, 1. Instantly, the widget rotates to a 45-degree angle. Now, let's change the up axis to 0, 1, 0, and it snaps to a 90-degree rotation. This gives us precise angular control in world space. Now, let's switch to bone space and set the up axis to -x. This locks the widget's orientation directly to the bone's local transform. As the bone rotates and moves, the widget perfectly mimics its rotation. This allows you to create UI that behaves as a natural, rigid extension of the skeleton itself. Now, let's look at controlling the rendering order. By default, the mesh, as the parent, renders at the bottom layer, while child widgets render in their slot order, just like in a canvas panel. To manage depth in 3D space, we can change the child draw order parameter. Let's switch it from slot order to bone distance to camera. Now, the child widgets automatically sort based on their bone's distance to the camera. Widgets attached to bones closer to the camera will render on top, creating proper 3D depth. By default, the mesh itself remains at the bottom, but we can make it participate in this sorting. Now, let's enable Mesh Sort Bone and set the Mesh Sort Bone to the character's root bone. This tells the system to use the root bone's position for the mesh's sorting depth. Now, watch what happens when the character turns around. As the character turns, the UI element is now correctly rendered behind the mesh. This creates a perfect and accurate depth relationship, where the 3D model can naturally occlude the UI when it's in front, just like any other object in the world. And that's it! With the new Simple Mesh widget, you can now seamlessly attach any UI element directly to your skeleton, control its size and rotation in 3D space, and achieve perfect depth sorting. Thanks for watching!